All right, welcome back. We're going to continue on with probability. We'll go to page 26, which is on expected value. Flip down here, page 26. Expected value could be abbreviated like that, so you might see it either way. They mean the same thing. Well, expected value is exactly the way it sounds. It's what do you expect to happen? What value would you expect to see? So I want you to kind of think about it in terms of that definition. So if I want to actually calculate the value that I would expect to see, I need a little situation. So let's take, for example, our spinner. So we have a spinner that looks like this. Again, we'll cut it kind of nice, little 90-degree there. So this will be spinner number 1. And we're going to spin, and we're going to spin for points. So let's say your next test grade, you get to spin the spinner. You get 10 points if you land there. You get 3 points if you land here. Then you get to spin spinner number 2. I guess I should have made them worth a little bit more. That's okay. And then bad things happen on this spinner. If you spin this one, if you land here, you're going to lose 8 points. And if you land here, you're going to lose 4 points. Oh man, you're going to end up with negative points. That's no good. All right, so let's take a look at what would happen in the long run if I were to play this game. Like, let's say you could spin the spinner as many times as you want. All right, so the expected value would look something like this. So the way we figure that out is we need to know the probability that certain outcomes will happen. And then once we know those probabilities, then we can figure out how many points that are associated with it. So for example, let's take a look at a little table. So like I said, we need to figure out the probabilities first. So on the first spinner, where good things happen, you could either get 10 points or 3 points. And then on the second spinner, where bad things happen, you could get 8 points taken away or 4 points taken away. So now let's figure out the probabilities of getting those. So in this section here, if I get 10 points and get 8 taken away, I'm going to be left with 2 points. The probability that I get 2 points, remember this is going to be, in the previous lesson we talked about this as being 90 over 360 or 1/4. And then the 3 points is going to be 270 over 360, which is just 3/4. So those are my probabilities right there. And then on this side, getting negative 8 points is going to be 1/2. You could see that, half of it's there. So the probability of landing there is 1/2. The probability of landing at -4 is also 1/2. So if I want to know the probability of getting 2 points, it's going to be 1/2 times 1/4, which is just 1/8. The probability of getting, if I land here and here, I'm going to get -5 points. Multiply those two probabilities together, and I get 3/8. If I land here and here, I'm going to get 6 points. The probability of 1/4 times 1/2 is just 1/8. And if I land here and here, it's going to be -1 points. And that's going to be 3/4 times 1/2, which is just 3/8. All right, so now to find the expected value, I've got to take the probability of getting those points. So what that means is I'm just going to take the probability, which is 1/8, times the amount of points that I would get. And I'm going to do that for each of these squares. So the next one, I'm just going to take 3/8 times -5 points, 1/8 times 6 points, and then 3/8 times -1. So I'm going to multiply all these together and add them up. And that's going to come out to be -1.25 points. So what does that really mean? Well, in the long run, as I play this game over, let's say 100 times, I'm going to lose 125 points. Or on average, I'm going to lose 1.25 points per turn. So that's what I'm going to write. I would expect to lose 1.25 points per turn. So is this a good game to play? No, not so much. So I'm going to change the game on you a little bit. Draw a little line like that. What I'd like you to do is I'm going to set up this part. I would like you to finish this part and find the expected value. And tell me, is this a better game to play for points? Right? This is not a good game because we're losing points here. Well, not a good game for you. Or anybody. I don't want you to lose points. All right. So let's say I change the spinners on you. Let's say now instead I make this 20 points. And I make this 5 points. And we'll still leave this as half. Half, you lose 8 points. And you lose 4 points here. So this is spinner number 1, spinner number 2. You're happy, you're sad. Go in and pause the video. What I'd like you to do is set up the expected value for this. All right, let's see what you got. So again, I'm going to make my table. I could get, this time, 20 points or 5 points. I should have done this as a tree diagram. That's okay. This is -8 and this is -4. So the probabilities are still the same because I never changed the structure of my spinner. So we'll go 1/4, 3/4, 1/2, 1/2. The only thing that changed now were the number of points I could get. So I could get 12 points here, still 1/8 probability. This one I'm going to lose 3 points, 3/8 probability. This one I'm going to get 16 points, 1/8 probability, and 1 point, 3/8 probability. Right now it looks even better. I'm getting even more positive points. All right, so now to calculate the expected value. All I got to do is take the probability times the value amount. So it's going to be 1/8 times 12 plus 3/8 times -3 plus 1/8 times 16 plus 3/8 times 1. Throw all that in the calculator. I would do these separate and then throw it all in the calculator, and it came out to be 2.75 points per turn. So in the long run, I would expect to gain, because that's positive, 2.75 points per turn. All right, so this is actually a better spinner to gain points. And there you go. Sorry about that. All right, thanks for watching, and I'll see you next time.